Note on the seventh problem. It is a problem on varying load type problem. So not varying cross section type. Read the problem statement. There is a 6 meter long hollow bar. Hollow bar that is not a solid, it is a hollow. So it has inner and outer diameters. Cross section is 140 mm diameter for the length of 4 meter. Out of 6 meter, 4 meter length, it has 140 mm diameter, and remaining 2 meter, that is remaining length, it is 120 mm diameter. So with respect to given problem, we should write the diagram. Full stop. The bore. Next, the bore diameter is 80 mm. That is, there is a central hole. That is inner diameter. That we call it as bore. That is 80 mm throughout the bar length. You need to find the elongation of bar. Is subjected to 300 kilonewton axial load, tensile load. Modulus is given 200 gigapascal. I think you have taken the problem, it is finished. So I will continue, solve this. So this is the given problem statement. So we have a bar of total 6 meter length. So first it is having a diameter of, so this diameter is how much? What is the diameter? 140 mm. It is 140 mm. 140. 140 for the length of how much? For the length of 4 meters. 4 meter length diameter 140. 4 meter. Next, for the remaining cross section, this diameter is how much? For the remaining cross section, for the remaining length, the diameter of the bar is 120. 120 mm. Remaining length ಅಂದ್ರೆ what is the remaining length? Total 6 meter ಇದೆ. So if it is 4 meter one side, another side it will be 2 meters. Right? And so it is a hollow. Cross section of the bar is hollow. It is acted with tensile force. It is acted with tensile force of 300 kilonewton. So it is simple problem. Only thing is diameter is different. It is a hollow. You need to take instead of pi d square by 4, pi d square minus 5 by 4 into d square minus capital D square minus small d square. Outer diameter and inner diameter. So what you need to find? They are given modulus E ಕೊಟ್ಟಿದ್ದಾರೆ. E is 200 gigapascal. So giga in the sense 10 power 9. Right? How much? Convert this gigapascal to pascal. 200 ಅಂದ್ರೆ 10 power 9 ಬರುತ್ತೆ. So we'll convert this to 200 into 10 power 3 megapascal. 10 power 3 megapascal. So 9 ಇದರಿಂದ 3 ತೆಗೆದ್ರೆ remaining is 10 power 6. 10 power 3 ಆಗುತ್ತೆ. 10 power 6 ಅಂದ್ರೆ mega. So megapascal is nothing but Newton per mm square. ಎರಡು ಒಂದೇ. So first units ಬರ್ಸಿದೀನಿ. Problem ಮಾಡಬೇಕಾದ್ರೆ. Megapascal is nothing but Newton per mm square. Right? So E is 200 10 power 3 megapascal. So here we have two steps, one for 4 meter, another one for 2 meters, but load is only single load. It is varying cross sections for same load. Load is same. So it is first last class previous class it is similar to that. In the problem they have asked you to find total change in length or deformation. You need to find delta L. So we have two sections. One, if you consider this is first part. So this is second part. So you find out delta L1, delta L2. So add both, you will get delta L, right? So first, before going to that, you find out the area. Area A1, area of cross section for the first step. We consider that as first. Section 1, first section. You consider, you find out the area. What is the area for hollow section? 5 by 4 d square minus d square. Capital D square minus small d square. So this is D1 and just for your reference. So capital D1 is 140. So we have D1 is 140. Small D1 is how much? Just put it there. Bore. Bore is given. How much?
80.
That is 80. Small D1 will be 80. So substitute, you find out A1. Next, similarly for section 2 you find section 2 ಮತ್ತೆ ಬರೆಯಲ್ಲ formula directly you find A2. What is the area of second section? Diameter same ಆಗುತ್ತೆ, that is capital D will be 120, small d will be 80, it is same for section 2. So what is A1, what is A2 you find.
A1 10.368 into 10 power 3 mm square.
A1 is 10.36 is to 10 to the power of 3 mm square. Units correct ನೋಡ್ಕೊಳ್ಳಿ ಆಯ್ತಾ, ಇಲ್ಲೇನು ಪರವಾಗಿಲ್ಲ, ಇಲ್ಲಿ ಲೆಂತ್ ಮೀಟರ್ ಇದೆ ಅವಾಗ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೊಬೇಕು. ವಾಟ್ ಈಸ್ A2? A2 same, A2 ಅಲ್ಲಿ D2 minus D2 square, D2 remains capital D2 is 120, small D2 is same 18. Find out the area at this second section.
Six point two into 10 power 3 mm square. A2.
A2 is 6.2
into 10 power 3 mm square.
3 digits ಹೇಳ್ಬಿಡಿ ಆಯ್ತಾ, whenever you are taking power into 10 power ಎಲ್ಲ ಬಂದಾಗ 6.28 3 6.283. So whenever you are taking into 10 power 3 ಎಲ್ಲ ಇಡಬೇಕಾದ್ರೆ at least 3 decimal place you fall into 10 power 3 mm square. So this is you found the area for the respective section 1 and 2. So now you find total deformation. What is the equation? Total deformation delta L or DL, we can take delta L is equal to delta L1 deformation of section 1 plus deformation of section 2, delta L1 plus delta L2. So what is delta L equation, you know, P L by A. Is P L1 by A1 E. P load constant ಇದೆ, so it is, we take it as P only. Young's modulus ಸೇಮ್ ಮೆಟೀರಿಯಲ್ ಇರೋದ್ರಿಂದ ಇಟ್ ಇಸ್ ಕಾನ್ಸ್ಟೆಂಟ್, ಅದಕ್ಕೆ ಇ ಅಂತಾನೆ ತಗೊಂಡ್ವಿ. ಫಾರ್ ಸೇಮ್ ಪ್ರಾಬ್ಲಮ್ ಬೇರೆ ಮೆಟೀರಿಯಲ್ ಕೊಟ್ಟಿದ್ರೆ, ಬೇರೆ ಎರಡು ಮಾಡ್ಯುಲಸ್ ಡಿಫ್ರೆನ್ಸ್ ಕೊಟ್ಟಿದ್ರೆ ಎರಡು ಸೆಕ್ಷನ್ಗೆ E1 E2 ಅಂತ ತಗೋಬೇಕು, ರೈಟ್? ಸಿನ್ಸ್ ಇಟ್ ಇಸ್ ಸೇಮ್, ಐ ಆಮ್ ಟೇಕಿಂಗ್ ಇಟ್ ಆಸ್ E only. So at 2 it is PL2 by A2 into E. So you find out total delta L. How much? Substitute and find. This total delta L you find.
One point 056 mm.
Total delta L is 1.056.
Oh, it's 6 mm.
Yes, 1.056 mm. Units. So be careful. Don't let the units. Write the units. If you're missing it, it is you're going to lose the marks. So units the meaning right? So this is the solution for this current problem. Okay. So I finished. You can take next one. So note down this 8. Note down this 8th problem. Take down this 8th one. So it is 8th one. It is wearing load type problem. Yeah, finished. Okay, I think you have taken this. So the same sketch I have written there. Same, same sketch I have written. So the problem is that so it is just some member. So it is been hanged at certain top. At the top it is supported. At the top it is supported. So whenever it is just imagine just like a fan, it is sealed to the ceiling with the support. So what happens? It is when it is fixed at one end. When it is fixed at the one end, due to self weight, it is acting downwards, right? It is the block is due to the self weight. So the due to the self weight, what happens? It is at the support, the reaction exists. At the support, whenever I'm holding at certain point, the support will have certain forces will be acting at the support due to the self weight of the block. At the support, there will be a reaction force. Reaction force. So that is not given in this case, the reaction force. So here we have a block. So I will divide this into capital A, B, C, and D. So I have divided this, right? At A, there is a support. There is a support at the point A. Due to the self weight, what happens? At the support, there exists a reaction. There exists a reaction. So this reaction ಯಾವ ತರ act ಆಗ್ತಾ ಇರುತ್ತೆ ಅಂದ್ರೆ, so this reaction, so as the block is self-weight acts to the gravity, it is towards the gravity, the self-weight will be acting downwards. So then the reaction will be acting in the opposite direction, in the opposite direction. So hence, this you need to show the reaction in this case. So this reaction will be in the upward direction. Reaction will be in the upward direction, right? So reaction na ಬರ್ಕೊಂಡ್ಬಿಡ್ತದೆ ಕೊಟ್ಟಿರಲ್ಲ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ. So you need to write the reaction. Why? How to write the reaction? That is opposite to the direction of the weight. The reaction exists or acts opposite to the direction of its self weight at the support. So since it is the block is hanging, the reaction will be acting in the opposite direction to the self weight of the object. Since object self weight will be acting downwards, the reaction will be acting in the upward direction. So is one point ಬರ್ಕೊಂಬೇಕು. So the reaction will represent this reaction as R, capital R, capital R. So there are two unknowns here. There are two unknowns. ಒಂದು P, P ಕೊಟ್ಟಿಲ್ಲ. You need to find out P. Also you need to find out R, reaction also. Okay. For my convenience, I'll write this vertical diagram in the horizontal manner. Here. Since at the support, I've taken R. R is the reaction force. So R will be acting in this direction. If you I'm just reversing this diagram from vertical to horizontal. So this is R. R is the unknown, and P is P. The procedure is same. Also solved in the last class. But only thing here you should take R. Why you need to take R? Because it is a support. Since at the support, the reaction force always exists. Yeah. This is our diagram A, B, C, and D. So there are two unknowns in this. One is P, the unknown force, and the support reaction R you need to find. Same thing, you need to divide the block into, I have divided the block into different parts. One is AB, BC, CD. Same procedure, draw the equilibrium diagram. So what else it is given in the problem, you read? There is a steel bar. Area of cross section is given. How much? Area of cross section of the bar, that is constant. A is how much? 500. 500 mm square. Area of cross section. It is a loaded as shown, and modulus is given. Throughout the section, it is common material. Modulus is 200 gigapascal. So it is 200 into 10 to the power of 3 megapascal. Megapascal on the Newton per mm square. It is in mm. So what is the length? The length of the bar, you know, that is given. And right, 400 and 300 mm. So these are the length of the bar. So now individually you draw the equilibrium of individual section. So consider first case, consider equilibrium of bar AB. So you consider AB. So I'll just consider the first block, that is AB. So for AB you draw the equilibrium diagram. So if I consider AB, so this is A, B. So what are the forces? So before going to this, ಎರಡು unknown is. I don't know what is reaction. Reaction only. So what is the force that is acting? I don't know. Right? So first you find out R in terms of P. In terms of P. For totally the forces has to be balanced. Totally the forces to be balanced before going to draw the equilibrium diagram for AB. So first, under total equilibrium, you consider under equilibrium. So what happens under equilibrium? The sum of forces is what? Under equilibrium condition, just forget about AB. If you consider the whole diagram under equilibrium, for the bar to be in equilibrium, sum of all the forces, that is, should be zero, right? When you sum all the forces, it should be zero under equilibrium condition. So consider that under equilibrium, sum of all the forces should be equilibrium. When is the sum of all the forces should be equilibrium? When the forces acting to the right and forces acting to the left are equal, right? In that condition, the forces acting will be under equilibrium for the respective bar. So if I consider this diagram, so there is 30 kilonewton which is acting to the right, that is tensile. And what are all the other forces? Other forces, if you consider R, if you consider P, and if you consider 10 kilonewton, these three forces are acting to the left. So this 30 kilonewton should be equal to R plus P plus 10, right? So that is the under equilibrium condition, sum of forces are zero. That is R plus P plus 10 should be equal to 30, right? Should be equal to 30. That is 30 into 10 power 3, 30 kilonewton, or 30 is just right. Right? You got this right? The sum of all the forces should be zero. So by looking at the diagram, the forces to the right should be equal to the forces which are going to the left. That is, tensile force should be equal for the bar to be in equilibrium. So now you just reduce this. So what is that? Because the kilonewton, if we can take it in kilonewton only. So it is kilonewton. So afterwards you can take 10 power 3. So illu aste. It is 10 kilonewton. 10 kilonewton, that is equal to 30. So what is R plus P? R plus P is equal to 30 minus 10 is 20. Is 20 kilonewton. R plus P is 20 kilonewton. So what is R? R is equal to 20 minus P. 20 minus P. So it is in kilonewton. So we get it in kilonewton. So kilonewton, you know this. The unit is in kilonewton. Right? First you find R in terms of P. ನನಗೆ ಎರಡೆರಡು unknown ಇದ್ರೆ ಗೊತ್ತಾಗಲ್ಲ ಒಂದು what is R and what is P. So we got R in terms of P. By considering the equilibrium condition, sum of all the forces should be equal to 0. So right, by considering this, when you add and all the forces, I got R is equal to 20 minus of P. Right. So now you consider this equilibrium diagram for individual section AB. Right. So what is the force acting at A? When you consider this, it is only R. It is only R. It is only R. So I'll just, what is the direction? It is going to the left. So what is R? R is 20 minus of P. So we know that the kilonewton is that we'll take afterwards. So R is 20 minus P. So this is the force acting at A. Right? So next, if I consider B consider madadre, so you consider all the forces at the point B and to the right of B, to draw the force diagram. So since direction is only one force is there at A, so the direction which is at B has to be in the same direction. So now you add all the forces. At B, ಯಾವ force ಇದೆ? ಒಂದು P ಇದೆ. P is tensile or compressive. P is tensile or compressive.
Compressive.
Yeah, it is compressive. So it is plus or minus? It is minus. It is minus P. Then we have one more 10. That is at C, it is coming into the point B. So this is also compressive. So it is minus 10 once again. And at D, it is going forward. That is tensile. So it is plus 30. So what is the total? It is 20 minus C. When you subtract this, it will be 20 minus C. Right? So this is the equilibrium diagram for AB. So now you draw them. So you'll consider this as section 1. Section 1. What is the deformation? Deformation of section 1. Delta L1 is equal to P L1 by A E. A constant, E constant. So what is the load? Load is 20 minus P. 20 minus P. Right? So substitute here and find out what is delta L1. Delta L1 in terms of P you will get. It is P is the unknown here. You will get 20 minus P into something you will get. What is that total? 20 minus P into what? So just keep 20 minus P as it is into 10 power extra bharat minus 3 extra bharat. How much? Minus P into 10 to the power of. So A is known. Kottidare 500. Length is, for this section it is 500. So 500 get cancelled. Alva. Next modulus is 2 into 10 to the power of 5. Right? So this is in kilonewton. This is in kilonewton. So substitute this as 20 minus P into 10 to the power of 3 ಹಾಕಬೇಕು. ಸಾಲ್ವ್ ಮಾಡಬೇಕಾದ್ರೆ 10 to the power of 3 into 500 divided by 500 into 2 into 10 to the power of 5. So why is this 10 power 3 andre? This is in kilonewtons. So it is kilo has to be substituted. Substituting to be done in newtons. So or else you just keep this as in fraction only. ಏನಿದೆ ಅದನ್ನ ಇಟ್ಕೊಂಡ್ಬಿಡಿ. So it is 20 minus p. So at last we'll substitute into 10 to the power of 3 divided by 2 into 10 to the power of 5. Just keep this as
Sir. Yes, sir. Yes, sir. ಕೇಳಿಸ್ತಾ ಇದೆ ಈಗ.
Okay, it is audible now. Akash, ಕೇಳಿಸಿದೆಂಪ ಈಗ? ಕೇಳಿಸಿದಲ್ವಾ?
Yes, sir. ಈಗ ಕೇಳಿಸ್ತಾ ಇದೆ.
Okay. So now you just find out delta L1, that is the deformation at this first section. So just keep that as unknown, just as it is in fraction is as 20 minus p into 10 to the power of 3 divided by 2 into 10 to the power of 5. Just keep it. Next, you get the equilibrium diagram for BC. Then find the change in length for BC. ಇಲ್ಲಿ 10 to the power of 3 ಏನಂತ ನೋಡಿದ್ರೆ it is in kilonewtons. So it is 10 to the power of 3. Okay. Fine. Now you continue with this. So this is the delta L1 for first section. Next, you draw the equilibrium of BC, bar BC. So what are the forces you draw? So this is BC. If you consider BC at point B, so what are all the forces at point B? To the left of B, one do P there, P, which is going outwards, so it is tensile. So at B, then at to the left of B there is A, which is acting at point B, right? So that is also R. R is also going away. So it is P plus R, right? Correct? So it is R plus P. So what is the direction? It is R plus P. It is tensile. ಎರಡು ಆಚೆನೆ ಹೋಗ್ತಾ ಇರೋದ್ರಿಂದ it is tensile, right? Next, you draw the force at C. C ಅಲ್ಲಿ ಯಾವ ಫೋರ್ಸ್ ಆಗ್ತಾ ಇದೆ? ಒಂದು 10 ಕಿಲೋ ನ್ಯೂಟನ್, ಇನ್ನೊಂದು 30 ಕಿಲೋ ನ್ಯೂಟನ್. To the right, how to take the force? At point C ಯಾವ್ದು ಆಗ್ತಾ ಇದೆ ತಗೊಳ್ಳಿ. Next, to the right of C, whatever the forces are there, you just take. So if it is tensile, it is positive. If it is compressive, it is negative. So at point C, 10 kilonewton is compressive, tensile.
Compressive.
10 kilonewton is compressive, right?
Compressive.
10 kilonewton is compressive. So what about 30?
Tensile.
It is 10 under compressive. It is minus 10 plus 30. So it is plus 10 minus 30 is how much? 20 kilo Newton. So what is the direction? Direction it has to be same as this. Since 20 is 30 ಜಾಸ್ತಿ ಇರೋದ್ರಿಂದ it is 10z. It is 20 10z. So what is the force? At other direction it has to be same 20 kilonewton. So R plus P should be equal to 20 kilonewton. So right, ಈಗ ಒಂದ್ ಕಡೆ ಬಂದ್ರೆ ಸಾಕು, right, 1/2. So it should be same as that in the other direction also. So I'll directly write it as 20. So now you calculate deformation of, so we'll consider it as 2 delta L2, that is P L2 by AE. How much? Fine. P ಅಂದ್ರೆ 20.
0.0.
Is P2. P is P2. ಎಷ್ಟು ಬರುತ್ತೆ ನೋಡಿ. P is P2. That is 20. Tensile positive. P is positive. How much?
0.08.
0.08 mm. So it is equal to 0.08 mm. So next, similarly you find equilibrium of bar CD. Bar CD. So if you consider CD, so if you consider this section, so to the right of D there is only 30 kilonewton. There is only 30, directly you write, it is tensile, 30 kilonewton. Next, to the left, it has to be same. A direction after one, to the left also direction, directly you write, then you add the forces. So at point C it is tensile 10 kilonewton. Point P is also tensile. R is also tensile. It is R plus P plus 10. Right? It is equal to R plus P plus 10. So that is, if you add, you will get same. That should be 30 kilonewton. Directly you can write. Since I know the force at one side, for equilibrium condition, it has to be same in the other direction also. So now you find delta L3. So we'll consider this as section 3. So delta L3 is equal to P3 L3 by AE. How much?
0.09 million.
It is 0.09. It is 0.09 mm. Now you find the total elongation of the bar or total deformation. You know, question ಒಂದು sentence ಕೊಟ್ಟಿದ್ದಾರೆ. You read the question statement. So what is that given? ಏನು ಕೊಡಿ ನೋಡಿ last sentence. So that lower end does not move vertically downwards. That is, if this total length of the bar is, what is that, 500 plus 400 plus 300, the total length ಅಷ್ಟೇ ಇರುತ್ತೆ, but there is a deformation in between. The lower end, ಇದರಿಂದ it should not move downwards from this position. So it can vary internally, but it is not going to move downwards. So that the total deformation, that is a total elongation of the bar, is how much? According to the given sentence, the lower end of the bar will remain in this position. It is not going to increase from this position, from the lower end. It is not going to increase from the lower end position. So that is given, as the sentence is given, the total deformation of the bar is 0. That can be taken. So that is delta L1 plus delta L2 plus delta L3. It is given in the problem statement. It is given that delta L1 plus delta L2 plus delta L3 is equal to 0. It is given. So read that last sentence. The lower end is not moving from its position. So as it is given, the total deformation is 0. So that is from the given statement we have taken. So now you add all the deformation and make it equal to this 0 to find the unknown P. So you add delta L1, L2, L3 equal to 0 and find P. What is P you find? ಬೇಕಂದ್ರೆ ಬರ್ಕೊಳ್ಳಿ ಆ sentence before writing that equation. Since the bar must not move vertically downwards, since the bar must not move vertically downwards, the total change in length is equal to 0. The total change in length is equal to 0. So that is delta L1 plus delta L2 plus delta L3 is equal to 0. Now you find out what is P. You know what is delta L1, you add out all the things. So find out P, how much it comes. Just per third. Just a simplification.
20.8.
20 ಬರುತ್ತೆ. P here 54 ಏನೋ ಇದೆ ನೋಡಿ. 54 ಬರುತ್ತೆ ನೋಡಿ ಇನ್ನೊಂದ್ಸರಿ. ಇಲ್ಲ, it is 20 minus P into 10
Sir,
power
54
3.
kilonewton.
Yeah, P is 54 kilonewtons we get. P is 54 kilonewtons. So you know the equation. R is equal to 20 minus P. R is equal to 20 minus P and find the reaction. So what is reaction? R is equal to 20 minus P. How much? It is minus minus 34. So R will get minus 34 kilonewton. So these are different type when compared to last we have solved. Unknown kotirtare. If unknown is given, you need to find in this procedure. Some of the data will be given. Like in this problem, they are given one data like instead of giving the deformation, illi 0 anta kottidare. The bar is not moving anta kotta, it is 0. Instead of giving this, some value kotirbodu. The total deformation is equal to some value anta kotirtare. Right? Directly kotirtare. So total deformation kottidare, it is sum of all the deformation is equal to given value. That's it. So this finishes the problems on bars with varying loads and varying cross section. So next we'll move with next topic in this module in the next class. So we have one derivation on taper section and rectangular cross section bar. Derivation for change in length. For now, till now we have studied a bar with uniform cross section and stepped bar. But now, for a single bar, if it is tapered, or if it is trapezoidal in nature, then what is the deformation equation? The deformation equation changes. That we have a derivation for that. That we'll do in the next class. Okay. So you mark the attendance, I think. Just mark the attendance. So don't have any doubts, you can exit.